the isosceles triangle theorem, and this is what's going to be given to you. Just this, you're going to be asked to prove this statement. So let's read through this statement and let's understand what's being said here. So it says two sides of a triangle are congruent if and only if the corresponding angles are congruent. So this implies two directions, right? And I wrote the first direction. I say if two sides of a triangle are congruent, then the corresponding angles are congruent. And that's one direction. But the other direction, right, is if two angles of a triangle are congruent, then the corresponding sides are congruent. And you're going to have to write out this, both directions. You're going to have to write out this direction and then this direction and prove both directions appropriately. So let's start with this first one. So this first one, we could start by writing proof. And you could even draw a little picture here. You could say, right, you can see what this is saying. This is saying two sides of a triangle are congruent, making it what's called an isosceles triangle when exactly two sides are congruent. So you start off with AB being congruent to BC. And let's write this out. And what do I want to prove? I want to prove that the corresponding angles are congruent. So we have here statements, reasons. We're going to start with one of just being that I know that these two sides are congruent. AB is congruent to CB. And that's just what's given, that the two sides are congruent. Now, let's see what we have here. What does this word corresponding mean, right? I want to prove that the corresponding angles are congruent. So I'm going to draw, right, this side, BC. Its corresponding angle is this angle right here that I put a 1 on. Okay, and we need to be able to identify what the corresponding angle is given a side. So here I have side AB. Its corresponding angle is that angle 2 right there. And now let's read what this statement says in this one direction. So if two sides of a triangle are congruent, then the corresponding angles are congruent. So these two sides are congruent. This side is congruent to this side. Then their corresponding angles are congruent. So then that means that angle 1 has to be congruent to angle 2. And that's what we want to prove. We want to prove that angle 1 is congruent to angle 2. If all I'm given is that two sides are congruent, I want to wind up showing that the corresponding angles must be congruent. So I start off with that. I have that the two sides are congruent. Now let's see what we have. Okay, the next thing, what I'm going to say is, and this is really the only part that you're going to have to sort of remember, right? You don't have to remember much. You just have to remember that what you're going to say now is you're going to say that M is midpoint. Why do you got to remember that? Because it just seems like it comes from nowhere, right? And when it comes from nowhere, that's the real one that you got to remember. M is midpoint of segment AC. And all you got to say is that there always exists a midpoint for every segment. There exists a midpoint for all segments. And I'm going to try and cut this off here. For all segments. Okay. And let's put where M is. Let's just make, I don't know, some point M. And we know that M is the midpoint. Okay, now you write 3. And given that M is the midpoint, you know that AM, this side, is congruent to CM. And that's my definition of midpoint. So I have AM is congruent to CM. And that's definition of midpoint. For Okay, now you want to sort of see what we have. Now what do we have? We have that, let's say I draw this line BM here. We know that it's congruent to itself by reflexivity. So I'm just going to say that BM is congruent to itself by reflexivity. Reflexive or reflexivity, whatever. Reflexive. 5. Now your next statement is that if you look at this, right, triangle ABM is congruent to triangle CBM by side, side, side. So I have that the two triangles here, ABM, is congruent to triangle CBM. And that's because of side, side, side. I have three sides, right? This side, AM, is congruent to MC. This side, BC, is congruent to AB. And then this side is congruent to itself. They share that side. Now, with that fact, right, once you have that, and I'm just going to continue this. So here's my statements. So this will be 6, right? Statements, reasons, right? Continuing, statements, reasons. With that fact, now I know in this last step, I know angle 1 is going to be congruent to angle 2. And that's because of the corresponding parts of a congruent triangle are congruent. C, P, C, T, C. Okay? And you're done with this direction. I showed that angle 1 was congruent to angle 2. And I'm done. Now that's one direction. Now you got to go in the other direction. And really, there was only one thing that you needed to remember in this, and that was just to put a midpoint in this one, right? Once you have that, then you prove that these two triangles are congruent, and then all the corresponding parts must be congruent, right? Once you remember that midpoint, right, you should see that then you draw that line, BM, you see you have two triangles, prove that the triangles are congruent with side, 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 and then all the corresponding parts must be congruent. Now, in this one, there is something that you want to remember in this proof, just like how you want to remember the midpoint in the other one. But now in this one, let's draw the picture, right? So what's the picture look like in this case? In this case, I have that the angles are congruent. I have angle 1 is congruent to angle 2, and that's it. I want to show that the corresponding sides are congruent in this case. So what's the side that corresponds to angle 1? What's the side that corresponds to angle 1? Well, we should see that the side that corresponds to angle 1 is BC, right? And what's the side that corresponds with angle 2? So here's angle 2. The side that corresponds to angle 2 is side AB. So I want to show at the end of this one, given, right, in this case I know angle 1 is congruent to angle 2, that's what's given in this case. I want to wind up showing ultimately at the end of all of this that AB, this side, is congruent to BC. Now, how do I go about doing that? In this case, right, you want to use a similar idea, but I mean, not exactly. You don't want to put a midpoint on AC. You may be able to figure out a way of doing it that way. I don't know, but the way that I prove this typically is that excuse me, this here angle B. Okay, it must have an angle bisector. Okay, angle B must have some angle bisector. So let's call that angle bisector BM. And then let's call the angles that it created on either side 3 and angle 4. So let's write BM. Let's call this point M. And we don't know that that's the midpoint, right? We don't know. BM is angle bisector of angle B. And we'll just call this whole angle B. And that's because every single angle must have an angle bisector, right? Just like how there must exist a midpoint for all segments, there must exist an angle bisector for all angles. For all angles. So that's included with angle B, right? So let's say BM is the angle bisector of angle B. Then the next thing that you have here is that angle 3 is going to be congruent to angle 4. And that's just because of the fact that that's a definition of angle bisector. Right? Definition, it cuts the angle into two congruent parts. So this angle is congruent to this angle. So definition of angle bisector. Now the next thing, after that, we should sort of see where this is going again, right? BM is going to be congruent to itself, this segment. So let's write that. BM is congruent to itself. That's reflexive. Then I have, after that, I've got that. After I say BM is congruent to itself, I have an angle, side. An angle, side is for sure going to prove the two triangles congruent. So we're done after it is that after I prove the two triangles congruent. Because if the two triangles are congruent, then all their corresponding parts are congruent. So let's see. So now I know triangle ABM is congruent to triangle CBM. And that's because of angle, side. Right? I have an angle. I have this angle that they share. They share 1 and 2, or 1 and 2. 1 is congruent to 2. So then this angle is congruent to this angle. That's an angle. Then I have 3 is congruent to 4. So this angle and this angle. And then they share side BM. So it's angle, side. After I show that the two triangles are congruent, then I'm going to have that all the corresponding parts must be congruent. So AB must be congruent to CB because those are the corresponding sides. So B, C, okay, and that's CP, C, T, C. Right? These two triangles are congruent, therefore the corresponding parts must be congruent. So AB, this side, corresponds with this side, BC, and you're done.